welcome back to Math Mini Lessons. It's time for another geometry lesson. And here we're going to classify triangles and quadrilaterals. In other words, we're going to group them based on their properties. Things that we can see and measure in them. And we're going to use certain things we know. We're going to be able to use our lines. So when we see and recognize perpendicular and parallel lines, that is going to help us recognize certain things about triangles and quadrilaterals. We're going to be able to identify the angles by sight. So just by looking at them, is it acute, obtuse, or right? That's going to be very important for triangles. And then we're going to classify quadrilaterals and triangles using their features, their sides, and their angles. So let's jump in. Let's start by naming triangles. And there are two ways you can name them. You can name them based on the type of sides or by its angles. So what you're going to do for this, you're going to literally ask yourself two questions. So we're going to start with naming angles based on their sides. And the first question is, how many sides are equal? 0, 2, or 3? If you say all the sides are equal, all 3 sides are equal, then we call this an equilateral triangle because equilateral triangles have 3 equal sides. If you say only 2 sides are the same, then we call this an isosceles triangle. It just means they have 2 equal sides. And if you say none of the sides, 0, I have no equal sides, they're all completely different, then we call this a scalene triangle. So those are the first 3 terms that we use when classifying triangles. All right, jot this down into your notes. And here's our second question. If you want to name it based on its angles, you're going to ask yourself this question. Do I have any right or obtuse angles? That's it. That's the question you're asking yourself. So if your first answer is no, I don't see any right angles and I don't see any obtuse angles, well, then you have an acute triangle because it means all the angles are smaller than 90 degrees. If you say, yes, I see a right angle, just like this one here, like you see a right angle happening right there, then you say, I have a right triangle. It's right in the name, see? And then lastly, if you say, yes, I see an obtuse triangle, you guessed it, you have an obtuse triangle. So those are the 6 different names, one set of names based on its sides, and you just ask that question, how many sides are equal, or a set of names based on its angles. Do you see any right or obtuse angles? All right, hit pause and jot this down into your notes. Now let's look at the quadrilateral family, and it's a doozy. There's a lot of stuff happening in quadrilaterals. It's not as easy, but pretty much we know that quadrilaterals are just shapes that have 4 sides. Now there are a lot of special quadrilaterals because they have special properties. So we're going to ask some questions that will help us identify these really special quadrilaterals. The first question is, are there any parallel sides? Now if you answer yes, there's one set of parallel sides, then what you have is a trapezoid. And this is the trapezoid family right over here. They have one set. Oops, not that one. These 2 are parallel sides. They're never going to touch. But the other side, eventually, if you continued on, they would touch each other. Same thing here with this isosceles trapezoid. These 2 lines will never touch. But obviously, if I continue the other 2 sides, they would. And we're calling this an isosceles, just like with triangles, because they have 2 equal sides. Now, you could also say, yeah, both sides are parallel to each other. Well, then you have joined the parallelogram family. And parallelogram, literally parallels in the name, it just means that it has 2 sets of parallel lines. And everything in here is part of that parallelogram family, a rhombus, a rectangle, and a square. All right, and this little guy over here, this kite, no parallel sides, but this is special just because it does have some congruent sides here. So these 2 sides are congruent to these 2 sides here. So he's super special on the side. All right, let's look at the second question. Do you have all right angles, or is every single angle 90 degrees? If you say yes, then you have a rectangle. So that's this little family over here, the rectangle family. as well as squares. So I would ask that question, and these guys here have all right angles. And then we have one more question. Are all the sides equal? So if you have a quadrilateral of all equal sides, then you have a rhombus. And that's what this side of the family is over here, where these two have all equal sides. So I'm going to just label, here was our first question, is it parallel? So that's that first question we ask. And if you say yes, and both of them, then you're in a parallelogram. If you say yes, one of them, you're in trapezoid. And then if you ask that second question, do you have right angles? Here's question 2, do you have right angles? If you say yes, then you're following this little pathway and you have rectangles and squares. And our last question is, do they have all equal sides? And that's this little line over here of the family tree. So that's the rhombus family. Now, the last thing I am going to say is this perfect little square over here. Squares are super special, just like kites are special. So we said the kite has 2 sets of congruent sides, but no right angles. That's the kite. But our square, not only is it a rectangle, but it's also a rhombus. Okay, and I have this argument all the time with people. How can a square be a rectangle? Well, because it's part of that family of it has all right angles. So that's what makes it a rectangle. And that's what makes it a rectangle. It has all right angles. So squares have all right angles. And why is it a rhombus? Because all 4 sides are the same. So that's what makes it a rectangle and a rhombus. But that does not mean that rectangles are squares. Not all rectangles can be squares. It can only be a square if all sides are equal. All right, so let's hit pause and just jot these 3 questions down into your notes. A lot of terms. All right, let's look at our first model problem. We're going to use a lot of vocabulary to justify our reasoning. Is the triangle below best described, I meant to highlight, is the triangle below best described as a right, acute, or obtuse? Explain how you know your answer. So again, it's at the angle question. So I'm asking myself, do you see any right angles? And looking at it, no, I do not. I don't see any 90-degree angles here. And do I see any obtuse angles? And again, no, because our obtuse angles, think of it like you're opening a door. If I just opened it a little bit, it would be acute. But if I opened it straight, this would be 90 degrees. And if I opened it wider than 90 degrees, that would be obtuse. So nope, not obtuse either. So this has to be an acute triangle. There are no right angles and no obtuse angles, which means all of these are acute angles. They're all less than 90 degrees. So now I need to explain how I know my answer is correct. So that they're looking to see if you can, one, get the right answer, but can you also justify your reasoning? So here's the answer I came up with. And I'm going to show you what makes it a good answer. The triangle is best described as an acute triangle. So that's number 1. I'm answering the question right there. I'm clearly just saying it. Acute triangles have 3 angles that are less than 90 degrees. So I'm now defining the acute triangle. So I answered the question with the right term, and now I'm telling the person I know what it means. And this triangle clearly has 3 acute angles. There are no right or obtuse angles. So there's my second piece of evidence from my example here. There are no 90-degree angles and no obtuse angles. And that's all you really need for a really clear answer that explains that you know what these terms mean. Hit pause and jot this down into your notes. Right, here's our second model. Which shape is a rhombus? Explain how you know that you're right. So when I think of the word rhombus, when you remember we said 4 equal sides. And if you don't remember, you can always go back to your notes. So that's what we're looking for. Are there 4 equal sides? And look at how I annotate with little tick marks. So with A, I know these 2 are equal, so I put 1 tick mark. And these 2 are equal, so I put a different tick mark. So that's not a rhombus. It has two sets of equal sides, but not all four sides are the same. With B, it's a square, and automatically I know there are four equal sides. But you see how by me putting those tick marks, you could also see I know that. In C, these two are the same, but that's not a rhombus because only two sides are equal. That's just an isosceles trapezoid. And with D, I can see these two are the same, and then these two are a little longer, but they're also the same. So I can cross it out. Now, if you're doing the state test, you could also use a ruler just to verify that if you're worried about D and want to check it. But clearly we see that B is the correct answer. So now the second part is, can I explain my reasoning? So I'm going to have to show that I know which is the right answer, so answer the question. I'm going to have to explain that term a rhombus somewhere and then connect it to my answer. So let's see if I did that. B seems to be a rhombus, so I answered the question. A rhombus is a quadrilateral of four equal sides. I explained what a rhombus is. And now connecting to our work, B is a square, which is a rectangle with four equal sides. Done. I did all three things. Answered the question, explained that term, and then reconnected it to my example. So hit pause and jot this one down into your notes. And that's it for today's lesson. I hope you found this super helpful. I know there were a lot of terms in this one, so if you need to look back at your notes, that's okay. But keep those questions in your back pocket because that's just going to help you classify those triangles or quadrilaterals. I'll see you in the next lesson, Math Marbles. Bye.